All right, so in the first 7 miles of the Earth atmosphere, the air cools as the altitude increases. So the following graph shows the temperature change in Y in degrees Fahrenheit at an altitude X miles. Okay, so this is going to be our miles, and this is going to be our temperature change. And so does the graph represent direct variation or inverse? Well, that's a pretty straight line, so I would say that's going to be a direct variation in this case. So we'll go ahead and say that. Now, find an equation that models the data in the graph. Well, we've only got 2 points that we really know. It looks like one's at 0, 0, and one's at this. So what we have is slope is equal to change in y. So minus 96 minus 0 over, and then we have 6 minus 0. And so that's, excuse me, so that's going to be the minus 96 divided by the 6. So that's going to be what, 16, minus 16? Okay. So we know the equation of the line because it goes through 0, 0, so it's just going to be the y equals minus 16 times x, and then plus 0 because the intercept is at 0. Okay, so that's our equation of the line. So that's part B. Is the constant proportionality k positive or negative in interpret? Well, it's negative. So basically, for every mile higher up, then we're going to drop 16 degrees Celsius, is what it's seeming like it's going to be here. And find the change in air temperature 2.5 miles high above the Earth's surface. Well, 2.5 is here. So that's going to be where we're at. So what is that going to be? I don't know, one, two, three, maybe a four. So it's going to be a drop of 40 degrees in temperature. I guess this is in Fahrenheit. So drop in 40 degrees Fahrenheit. All right, so that's the things that they're asking for. So the one I talked about here, for every, mile up in altitude, we drop, 16 degrees Celsius, Fahrenheit, sorry, Fahrenheit. Okay. All right, so that's how we would work on this one. All right, let's stop there and we'll come back for some more.